Tangible augmented reality interfaces offer a hands-on approach for examining objects and exploring the associated information. We describe two tangible augmented reality interfaces that can expose the adaptation of the information presented to users about objects in augmented reality environments. Our interface has been developed using the AR Toolkit, an optical-based system that calculates a camera's position and orientation relative to marker cards, so that virtual 3D objects can be overlaid precisely on the markers. The AR Toolkit uses the marker's outline to calculate the position for the object to be drawn. The pattern is used for the orientation and to determine which object should be displayed. The AR Toolkit is able to cope with steep angles and distances away from the camera. We are using an open hypermedia link server to supply textual descriptions about objects, which are presented as labels close to their respective features. We provide a mechanism for selecting labels using the orientation of the object, so that the label closest to the center of the screen is selected. Augmented reality environments offer great possibilities for displaying the relationships or links between objects. Whenever two objects with active links between them are visible, the links are drawn with an elastic line from the source to the destination features, with the description being displayed in the middle of the line. Open hypermedia link structures can be large, complex networks. When adaptation techniques are used, the complexity of the resulting information space is increased. It is desirable to allow users to not only control the visible hyperstructure, but also the process of adaptation that generates each view. We have developed two tangible augmented reality interfaces that allow users to control the information that is presented to them. Our first interface is based on the notion of shaking information particles onto objects, thus altering the amount of detail presented in the labels. As users shake an information container marker, particles fly towards any visible objects, with information labels popping up and increasing in detail as the marker is shaken. If users wish to reduce the level of detail, they can shake the aircraft marker so that the information particles fly off. We provide different information shakers for different areas of information. Here, the user is adding labels describing the armament of an aircraft. This offers the possibility of mixing information and the label's contents. Here, the user is adding trivia snippets to descriptions of avionics features. Giving users the ability to mix and match the information they view about an object is very powerful, as they can discover different recipes of information that appeal to them. We are using particles scattered on the marker base to indicate how much information has been added to an object. Our second interface replaces sprinkling with spatial proximity. The distance between objects and information container markers mounted on circular disks modifies the amount of detail presented in the labels. When the information container is far from an aircraft, it has no effect, but as it is moved towards it, the labels pop up and increase in detail. When both markers are alongside each other, the maximum information level is presented in the labels. Rays are drawn from each information container to indicate how much of that particular type of information is applicable for an aircraft, with ray length giving the idea of the amount available. The glider has no armament, so no ray is drawn, but there is information available for the triplane. Faded out labels also indicate potential information, which is useful when mixing different types of information. Users need to activate and deactivate the information container to avoid affecting the level of information when they wish to focus on an object's labels. This is achieved by hiding information container markers when they are not required, either by turning them upside down or placing them outside the camera's view. Tangible augmented reality interfaces are powerful tools for displaying and manipulating virtual objects in the real world. We have presented two interfaces that go beyond simply displaying objects and related information, and actually allow users to control the information that's presented to them. The level of control offered results in a complex underlying information space, yet the interfaces remain natural and intuitive to use.